Okay, so we're talking about relative maximum, relative minimum. Another word, depending on the textbook, that can be used for the word relative is the word local. So sometimes you may see the word local, maximum, local, minimum. Okay? Now here's the idea with regards to relative maximum, relative minimum. All right, now I'm going to draw something that looks like this. So go ahead and do the same thing if you need to. Draw something that looks like that. Okay, now notice there are no grid lines at all. It doesn't matter for our purposes at this point. But I do have a function. And as I go, remember when we talked about increasing, decreasing?
Yeah.
Okay, so as I go from left to right, that was on your previous test, the intervals where a function is increasing or decreasing and constant. So as I go from left to right, my y values are doing what? And all of a sudden they're decreasing. Okay, so it changed at this point, right? Okay, all of a sudden it's decreasing, and then it's what? Increasing. So changed at this point. So here you kind of have a peak, and then you have a valley or something. And then it increased, and all of a sudden it did what? Decreased. Okay? And then here it decreased, and all of a sudden it did what? Increased. Okay. So here's what I need you to remember this. Remember, we're talking about local or relative. We're talking about local relative. We're talking about a small portion of the domain. We're not looking at the whole domain. We're looking at little pieces of the domain. And so relative minimum, well, let's talk about the word minimum. A minimum or maximum occurs when if you look at this little interval right here, this little interval, and that little interval, my y values go from increasing to what? Decreasing. Now, in this interval here, does that occur? No. It's always doing what? Decreasing. But somewhere in this interval, I go from increase to decrease. Somewhere in this interval here, I go from decrease to what? Increase. So the idea of local relative meaning a small portion of the domain. So if I go here, it also goes from where? Increase to decrease. And then here goes from decrease to increase. So we say that this function has a relative or local maximum at this point. So this would be considered a relative maximum. I'm going to call this a point for right now. So that's a relative maximum point. This right here would be called a relative minimum point. Remember, it's a low end, right? It goes from increase to what? I'm sorry, decrease to what? Increase. So you see that little valley? This is a peak. This is a valley. Relative minimum point. This is a relative maximum point. And this would be a relative minimum point. And that's all there are. These arrows keep on going down, right? This goes what? Up. Right, so that's all you know for right now in terms of this function. All right, now let's go to the handout. So the questions will usually be stated in different ways, though. So look at number 1. So I have this function. And the question is this: what is the relative maximum of f? Now listen carefully to what I mean by that. Notice I didn't say the point. I said what is the relative maximum of f. When I say the relative maximum of f, I look at the point. I do look at it. So notice this would be a what? A minimum. This would be a maximum, right? So it says I'm looking at the relative maximum of f. So when I ask what's the relative maximum of the function, I'm looking for the y value. For the way that question's written, you're looking for the y value. You're not looking for the point. You're not giving me the point, I should say. You give me the y value. So what's that y value? 2. So the relative maximum y value. So this right here is a maximum point. The y value is 2. It occurs, when I say the relative maximum occurs at, I'm talking about the x value. So it occurs at what x value? 1. So this is x value, this is what? Y value. So the relative maximum has a y value of 2, and it occurs when x is 1. Okay, let's go to part B. Now this talks about minimum. The relative minimum occurs when y is what? Negative 2. And it occurs at x equal what? Negative 1. That's the difference. Don't get them confused. So notice, what is the relative minimum of f? That phrase means the y value. So make sure you know that means the y value. So this is the y value. It occurs at, that's the x value. So if it's written like that, that statement, remember what that statement means. Okay? Now look at 2. Sometimes it can be written as number 2. Before we go to number 2, this would be a relative max. This would be a relative max. And this would be a relative min. So I think for the most part, you can tell me which points are relative maximums and which points are relative minimums. Okay, now state the local max. Now the plural, I have plural here. The plural for maximum is maxima. The plural for minimum is minima. So these are plurals. So state the local maxima. How many maxima are there? 2. Now the y values go here. So what's the y value? Oh, be careful. The y values are what now?
9.
It's just 9, right? That's your y value. Both of them. There are how many relative maximums are there? 2. But what do you notice about the y values? They're the same. So you just say what? 9. What is the relative minimum? First of all, how many minimum points are there? 1. What's that y value? What's that y value? 0. It does occur at the origin, but what's that y value of the origin? The maximum occurs at, remember, that means the x value. Where does the maximum occur at? It occurs at 2 places. What are they? Oh, yeah. So it's negative 2.5, right? So negative 2.5 is one of them. What's the other one? 2.5. And didn't you kind of know that this graph looks symmetric about the y-axis? That's an even function. So you see the opposites here, negative 2.5, 2.5. What about the minimum? Where does the minimum occur at when x is 0? All right. So remember, here, that's the y values that go here, and these are the x values. Y values, x values. Okay, number 3. Okay, look at the question. There's your function. Now, is this function even, odd, or neither? Number 3. Neither. Okay, so for the most part, you all can visually look at a graph and determine if it's even, odd, or neither. So that's neither. But it does have relative maximums and minimums. So, for example, this right here would be a relative what? Minimum. This is a relative max. This is a relative min. And this is a relative max. Okay, how many local maximums does G of F have? 2. Remember, the word local and relative mean the same thing. So 2 goes in here. How many relative minima does G of X have? 2. State the relative maxima minima. All right, now, when it says state the relative maxima minima, they're asking for the Y value. They're asking for the Y value. So look, just kind of like ASO here, right? What is the relative maximum? What is the relative minimum? Right here. So you look for the Y values. So the answer is going to be those Y values. So you're going to say, you could say like this, you could say the relative maxima is, one of them is what? 2. And over here it's what? 5. The relative minima, what's this one? -2. And what's this one? -6. Okay. Don't put those in parentheses because remember, it looks like you're indicating that 2, 5 is a point. Those are just Y values. They're both Y values. Look at number 4. What is the vertex of number 4? These are, you got, there are no grid lines, so just estimate. So let's see. Here's the vertex is right here, right? That's a vertex. So -2.7. Okay, yeah, that's fine. We can go with -2.7. You had the next part on your test. Where's it increasing? So it's increasing from. What now?
-3.
What are you talking about? The minimum of this one? No, look, it's right here. -2. Where -3 is right here. So use a rule if you need to. So you see where that's -2. That Y value is -2.
I'm looking at the wrong.
Okay. Remember, you're looking at the Y value, not the X value. You got to give me the Y values for those. So it's kind of difficult at times to like, what does he want, the Y value? Does he want the X value? Okay, so on your test you had stuff about increasing, decreasing. So you're increasing. Remember when we did that. So from in the interval from -infinity to -2, what was your graph doing? Increasing. So it's from -infinity to -2. Remember, it's always parentheses for those. And then for -2 to infinity, in that part of the domain, what did your graph do? Decrease. So -2 to infinity. All right, so that part B was from your last test. Now the new stuff is this. Does h of x have a relative maximum value or minimum value? Yes or no? Does okay, let me see. Does h of x have a relative maximum value or, oh, you got to put one of those. There's not a yes or no. I read it wrong. Does h of x have a relative maximum value or minimum value? Maximum value. So maximum value goes in here. Find the relative minimum or maximum value. So what's that maximum value? 7? 7, right? This occurs at x equal what? negative 2. So this occurs at x equals negative 2. Okay? So when it just says the words relative maximum, that's the y value. If it says occurs at, that's the x value. Occurs at x value. Okay? All right. So y'all all understand what relative maximum, how to locate the point, the relative maximum point, the relative minimum point, right? Okay. So if it says what's the relative maximum or the relative minimum, that's the y value you want. If it says it occurs at, that's the x value. Okay? All right, so I think it was just those problems, right? All right. So